Hey everybody, nice to meet you. My name is Jason Ostrander. I'm the VP for Commercial Operations at Frost Solutions. A lot of my work in the snow industry has been on the contractor side. Since coming on in Frost this year, I've been learning a lot about the municipal side and how effective that our mini weather stations can be. So enough about me. Let's talk about the station. If you want to go to the next slide, Allison. This will give you just a brief look at our mini weather station. That is an actual photo of our design. Solar panel driven, network driven through a cellular network, so it doesn't have to tie into anybody's network on site. And these are units that can be contained, on a pole, on top of a bridge, on top of a roadway. The greatest thing about these things is that, what the data is that they're able to give you, not only before, during, and after storms. Weather observations are recorded every minute to create location specific forecasts. So they're GPS located, right? So you get your whatever ecosystem you might have or a microclimate that you might have. It's going to be specific to that location. Wide angle day and night vision cameras are awesome. So you can get if you get a nice clean look at a road, you'll see a couple here in a minute. And then more recently, we've been working with AI to monitor photos, that will also not just give you surface and air and dew point temperatures through the actual IR reader on the unit, but also working to teach the units what they're seeing on the photos that they're taking. And possibly the most important piece for me that I used, and we use it as actually right now where I work, is the 72-hour forecast, which provides you the precip, road conditions, wind, air, surface temperatures, all things that are meaningful in numerous ways. But as it pertains to this, when do we send gals out to plow? Where do we have them salt? Where do we not have them salt? Let's skip on to the next slide there, Allison. So, forecasting is really kind of like the preeminent thing when you're in snow. Right now, I am also, in addition to working at Frost, I lead the operations for a contracting firm out of Long Island. So at any given snowstorm, we're sending out, well over 120 vehicles. And, when you have that many vehicles in comparison, you could have five, regardless, it's all important, right? But you want to know when's the best time to send people out. And if I rely on just turning on the TV, and looking at what they're forecasting, I don't know for you guys, for me this year, it's been very similar. Every snowstorm we had, they said it's either going to be between 2 and 22 inches. So, at that point, you're not really playing with a full deck when it comes to sending your vehicles out or your machines out. So bad or minimal data equals a bad forecast, right? If I don't have all the data points, I can't truly professionally rely on what it is that I'm seeing. At the end of the day, forecasting is difficult. That's why they say 2 inches to 20 inches because nobody wants to be wrong. They'd rather just be kind of right. So, but kind of right doesn't do it, for us in our industry. So, next slide, please, Allison. What we need to be able to do is we need to be able to forecast better. This is just a quick little glimpse of the online platform that if you would have your unit set up so you can see there briefly, you have the vision from the camera, and then below that, and we can zoom in later, and I can send you any of this if you want it. You can see the ebb and flow of the weather that you're going to be encountering for the next 72 hours. And that's going to give you not only surface temperature and air temperature, but it's also going to tell you what type of precipitation is going to be hitting at certain hours. The data that we collect on our device is up every minute, which is nice. It's not a forecast that updates every 5 or 6 hours. I mean, as that forecasts move, especially if you happen to be in a lake effect area, that forecast is moving with you. Basically, every 5 minutes, there's an update that's location specific for both pavement and atmosphere. And then we assess all data points and we try to, we record and assess all data points. For the contractors, that's important because oftentimes it can mean the difference of I'm sending out 5 guys 2 hours early and losing some operational, income there, or I'm sending 5 guys out 2 hours late based on, a forecast that would be faulty. So, and the greatest part about the units themselves is the longer they stay on those locations, they really learn and understand the characteristic of your pavement over time. So I have used several units in my day, the different places that I've worked at. More recently, we are in 5 states. So being able to throw units out in those different states and being able to make, a reasonable, an educated guess as to when guys should go out and where they should go has been powerful. So next slide. But the thing is that for us and what we're talking about here, how is this relevant to salt? I'm assuming that everybody on this call is either curious about or is actually advancing, the cause for less salt usage or appropriate salt usage, so that we're not, destroying our roads, destroying our equipment, destroying our environment. There's a lot of reasons why we would like to limit salt. And I guess the question that, I think Frost tries to answer is, how can we be a part of that solution? Next slide. So one of the things that happens when you're looking at pavement and air temps is, my wife will ask me, during the winter before I go outside, hey, what's the temperature going to be outside? She's asking, that question because she wants to know how much does she have to put on? How many jackets do I have to wear? How many do I need to wear gloves? Most people, when they're asking about temperatures, they want to know the atmospheric temperature. For those of us that work in the industry, and then when it comes to applying salt, we understand that realistically, the most important thing is the surface temperature. So you have here two different graphs of two different weather events. The one on the left, right, is going to contains data that, as you're looking at it, has an air temp of 41.8 and the surface temperature is about 30.8. The salt might be needed, if there's moisture present. So, and if there's not moisture present, then you just know the surface temperature is going to be low. On the right-hand side, what you see on that one is we have a forecast of air temp of 31.7 and a surface of 42. So you might be, cajoled into saying, hey, it's going to be 32 degrees, below 32 degrees. Let's make sure we salt. But if your surface temperature has been warm, if you had a warmer week, you're going to want to know when that surface temperature is going to hit. It may not be right off the bat, and there may be rain coming in the forecast, but our 72-hour advance notice will give you the option of knowing, hey, this is when you are below 32 degrees as a surface temp and there is precipitation in your area. That would probably be the better time to salt, not, 6 or 7 hours earlier based on, oh, it's cold outside. Next slide. And we know that salt actually has, varying degrees of efficacy as it gets colder. So commonly known, something you probably already know, the colder it gets, the more salt you have to apply to kind of break through until you get to that point, at that, that negative 15 below, where it's like, the eukaryotic's not kicking in. It's not going to actually do anything. You're going to have to apply a hot de-icer or something like that to break it up. But here's a great case in point. This is a typical event in Grand Rapids, and you can see that there are pockets of surface temperatures that are warmer and colder. If I had to go and now send out a crew to take this space, I could easily make decisions upon where I'm going to use more salt, where I'm going to use less salt, based on the road temps that I'm getting from the units that are there on site. You can see there's two little gray areas there, and they're showing temperatures below 15 degrees. That's going to make that really too cold for salt to be effective. So I might be able to reposition my trucks or my guys to go to other locations, or I might be able to inform guys at what speed I want to drive through lanes, or, for me, a lot of it's parking lots, but how I want to push them and give them kind of course correction from the beginning so as not to apply too much. Next slide. So this is just a real quick look. If you had, 7 units, 8 units at one time, you can pull everything up in your war zone, wherever you're doing your war room, you're doing your snow prep, and where you're watching it during the event. And you can see very quickly on the left side, there's a lot more, there's a lot more activity underneath those units. On the right side, not as much. And so quickly you're able to design, hey, it's all coming from west side to east, or east to west, or north to south, however you've kind of placed your units. And again, making an informed decision as to when you're sending and who you're sending. Next slide, please. So why does it matter? Why are you on this call? Why am I on this call? I mean, the recommended application rates for different pavement temperatures are there. If we just take a look at the left side, you can see varying degrees of surface temperatures, different brackets. And as that temperature goes down, your rock salt usage per lane mile is going to go up. At 28 to 32 degrees, it's recommended that you put down 150 pounds per lane mile. As you get down to 15 to 23, it's 250. Next slide. Now, this matters because if I look at, let's see, yep, that's the one. Thank you. Using pavement tends to adjust application rates. Keep in mind, I'm looking at a couple different things here. First of all, we're looking on an average application rate of about 300 pounds per lane mile is the normal application. But if you know that the temperature on that surface, it varies, you don't need the 300 pounds. So for example, 28 to 32 degrees, you're looking at 150 pounds that you would have to apply, which, if I'm paying $90 per ton, which this year there was a salt shortage, so guys are paying a lot more per ton. But on the 90 per ton rock salt pay, then I'm probably saving about $6.75 per estimated lane. And next slide, $6.75. I mean, what's the savings there? Ultimately that 675 has a lot to do, because if I'm taking that 675 and I'm assuming I'm treating the roads 4 times and I have 60 snow events, 40 with pavement temps above 28 degrees, that is $1,000.80 in savings for a single mile alone per year. If I'm doing 30 miles of road managed, this would be a savings of $32,000. And again, I do know that there's always human error, and some people you can say, hey, don't turn that thing all the way up, only turn it halfway up. They may or may not be listening. But if we can send out our employees with information at their disposal to be able to be more cognizant of what's going on the roads, then we're going to, treat them and give them kind of inroads into being better users of salt and making sure that we're being more effective. Last slide, next. Just gives you an idea of, kind of our mobile platform. So you saw the online version. Now the mobile platform gives you a quick scroll through. You can be looking at your thing, at your different units there. And just a couple of nice things that some folks said with us, the Illinois City Public Works, like helping, having up to the minute pavement temperatures available helps. On the right, a contractor said in the first month of having the unit, I bet we saved about 15,000 between salt and wages, and that's really the solution, right? We want to be able to save operating costs for our municipalities, for our contractors, and we obviously want to be using the right amount of salt on the roads. And if we have that information at our disposal, then I think that we'll be able to make those right choices. And over time, maybe we're wise all over the place with our salt usage. So that's it for me, Allison.
Thank
Okay,
you,
hi
Jason.
everyone.
Yeah, Eric, jump right in.
Yeah, thanks, Jason. That was really great. My name's Eric Faulkner. I'm a meteorologist with a company called Vizsla X Weather. So throughout my career, I've basically helped organizations manage their weather risk. I'm originally from Pittsburgh, Pennsylvania, but 9 years ago, I moved to Charleston, South Carolina, which is a little ironic because I deal with snow and ice, though we did get some snow this year for the first time in 7 years. I have a degree in meteorology from the Ohio State University. Huge Buckeye fan, so much so that I named my golden retriever Buckeye. So just a little bit of background about me. So road data, this is what we're talking about today. So this is all kind of information that you can collect from the roadways. Everyone on this call knows that salt and overuse of road salt is a problem. So how do we mitigate that salt usage as much as possible? Well, it's important to have all of this information you see popping up here right now. And really, why is this important? That's kind of what we're getting at, right? Well, Allison, you can go to the next slide. Well, road temperature variability is a huge challenge. Jason talked about it a little bit, but road temperatures can vary drastically along a network. I've seen it as much as 30 degrees in any given network. And I want you to focus on this screenshot. These are a couple of road sensors up in the New York area, right off Lake Ontario. And this was during a winter weather event, a lake effect snow event, where those two in the middle are only 5 miles apart from each other. And there's a difference of 10 degrees on the road temperature there. So ultimately, having this information just then helps in more targeted treatments. Allison, you can go to the next slide. This is just another example of variability across Madison, Wisconsin. You can see all the different colors. Those are symbolizing different road temperatures at the time. And these road temperatures ranged from 27 degrees Fahrenheit all the way up to 38 degrees Fahrenheit. So that's a wide range across a network, especially if you have a winter weather event, especially if there's precipitation involved and you're trying to thread that needle. And you can hit next a couple times. This also impacts the forecast. So this example is from eastern Wisconsin, right along the lake. And feeding in some of that road data really does impact the forecast, where in this situation, there was 5 inches of snow projected on the road surface at that southernmost point, and about half of that projected on the northernmost point. And then this is just more about variability, to be honest. Jason touched on this as well, but air temperature versus road temperatures. This was an example down in Memphis, Tennessee earlier this year. There was a lot of cold in January, southern snow events. This one was from February, right after one of their southern snow events. But the air temperature was 16 degrees. They were, wondering if they should go out and salt after the snow event to clean up any remaining snow and ice. But the road temperatures were in the mid 30s to mid 40s at that point. So they were able to avoid going out to salt and then just monitoring for the next night to see if road temperatures would drop below freezing. So just an indication of how you can utilize that data to minimize your salt use. So we know a little bit about variability, right? Road temperatures conditions vary widely. But what affects those conditions? Well, all these different things up here affect those road conditions and those road temperatures. However, what I'm focusing on this slide here is what the standard weather models incorporate into their forecast engines. So that's your atmospheric weather, your solar radiation, your topography, your large bodies of water, and to some extent, urban heat islands. But this doesn't give you all the information that you need of what's happening on the surface of the road for snow and ice removal. So that's ultimately where we come in. What we're trying to do, we're trying to integrate some of that additional information, like the traffic, like the maintenance activities, within a road weather model. Next. So how do we capture that variability? You guys might say, well, hey, I have ARWIS locations outside of my territory. There's some on the interstates. We have some cameras out there. We have the handheld thermometers where we can measure the pavement temperature, which is all great. Those are good tools and good resources to have. But what we're trying to do is we're trying to capture that very significant variability within any given road network. So we're trying to fill in the gaps where the data is absent and trying to collect more data in those areas. You can go to the next slide. So ultimately, how do we do this? There's a lot of ways that you can do it, and there's some new ways to do it with new technology. So this is not a new concept by any means. This type of thing has been around for a while, but what we've done is we've kind of shrunk it down to a more cost-effective, simplistic method on collecting road data, and it's through IoT sensors. And the great thing about this is that it's wireless in design, the batteries last for years, and they're maintenance-free operation. Also, the data is able to connect through cell signal. So as long as there is cell signal in the area, you're able to consistently collect data right on your roadways that allows you to physically see it on a screen rather than having to go out and do the handheld on the roadway. So that's one of the key things. You can focus on your primaries. You can focus on remote locations if there's good cell service. You can focus on shaded areas. All these different areas that you want to put your or put attention into. You can now collect data in those locations. So this is a quote from Kelly Maurer, the Director of Public Works at Cranberry Township, Pennsylvania. I love this quote. She said, "The best thing since brine." We all know how important brine is in salt reduction, and brine really modernized Cranberry's winter maintenance operation, and then the road data just took it to the next level. Next. So the key to this conversation is powering the forecast. So not only is this data being collected on the roadway, but we're also using that information from these, what I like to call mini meteorologists, collect that data, incorporate that into a road weather model that's more road specific than your standard models to produce a better, more accurate, localized forecast. This image will be important for the next example. If you want to go back one, thank you. Can you go back one, Allison? I'm sorry. And then just, yeah. So this image will be important for the next example here. So it's one of the IoT sensors, and it might be a little hard to see, but you can see the dead end road there on the bottom left-hand side with the shadow of that tree. You can go to the next slide. So this is where AI and machine learning comes into play, using the data to then improve the forecast. So in this example, you have your observations there on the left. You have that little dip in the road temperature, which is strange. It's not something you commonly see. And I was wondering what was happening here. Well, what was happening was the shadow of the tree was encroaching on the point where the road temperature sensor was. And when that shadow went over that area, obviously it would decrease the road temperature. And then when the shadow moved on, the road temperature would increase again with the sun hitting the pavement. The cool thing about this is what was actually happening is it was impacting the forecast. So Allison, if you hit next a couple of times, they'll pop up. But the observations on the left, the forecast on the right, and the forecast started picking up on that little dip. It doesn't know that it was a shadow of a tree. It just knows that something was happening to reduce that pavement temperature and increase it again. So with analysis that we've run, we've noticed 70% increase in accuracy in forecasts within the first 6 hours, up to 30% all the way out to hour 72, which is a big deal when you're trying to thread the needle when temperatures are close to that 32-degree mark. So this is a practical example of impacting the forecast. This is from Down East Maine. 2 different locations, again, maybe about 5 miles apart, not that far away from each other, and how different the forecasts are. The top one at Water Street, that yellow you see is snow accumulation on the road, where you go down to Pool Road, and there's no snow accumulation expected on the road surface there. So you can utilize this data and this information to have or direct resources up to Water Street, have heavier application rates there, and just kind of monitor Pool Road, a wait and see approach, or maybe do a light application for some expected minor icing eventually in the forecast. I'm going to go back to Cranberry. This is a real world example. So they're a township north of Pittsburgh, Pennsylvania. They're not huge by any means. So if you're thinking we're too small to take advantage of something like this with data, Cranberry is only 132 miles of road. So this was a really good example that I like to use because it was right after they got access to some of this data. It was 2 years ago, and the National Weather Service was calling for freezing rain. So they were really worried because their system was, or their data was saying road temps are going to be in the mid-30s and climb throughout the event, but they didn't want to mess around with freezing rain. So ultimately what they decided to do is they decided we invested in this. We're not going to do a call out. We're not going to spread any material. And fast forward to the next morning, road temps were in the mid-30s. They were climbing throughout the event. There was freezing rain on elevated surfaces, so there was some icing on trees and cars and things like that, but the roads were just wet and they were safe. And in this specific example, Cranberry was able to save $10,000 on a call out. In year 1, they saved $100,000 on labor and material. In year 2, they saved $160,000 on labor and material. Now, savings are important in the fact that you can then reinvest that money. If you were able to check out the latest webinar back in March with Ricky from the city of Glendale, he talked a little bit about this. Maybe you need or maybe you want to invest in a new brine tank or a new plow truck, and you want to use some of the savings, some of this money toward that, or another project within the community. You're now able to do that. But money's not the only thing. Also, they noticed quality of life advancement for their staff by being able to plan more ahead of time. And then just having that salt usage transparency with their residents, where communities around them were spreading a bunch of salt during this event and other events. And now they can have the justification to let their administration know, let their residents know, this is why we're not spreading salt and this is why it's benefiting you. You can click through this, Allison. This is just another example showing the differences of pavement temperatures over a very small area. The one thing I do want to point out here is the orange line at the bottom graph. So that shows the amount of salt that's on the road. So you can see where application happened and it peaked, and then the salt diluted out. And then in the forecast, there's more snow coming. So this also helps with timing, if there's residual salt on the road or not, and those projected or predicted application rates that you're going to use. These are a couple of examples of non-precipitation events. So not only is this good for, it's not only is this good for precipitation events, but it's good for things like frost and black ice to have this data. This is an example from Des Moines, Iowa, where the road temperature was dropping below the dew point, but it was below freezing, so condensation and frost would form. And then if you click next, Allison, the next one is from Madison, Wisconsin. Same deal. This one is just to show you the difference between frost and a precipitation event. So there's frost in the very near term, and then a precipitation event later to help with the timing and the preciseness of those application rates. Can you go to the next slide? So this is a quote I love from Tyler Berger, the Assistant Director of Public Works at the City of Oak Creek, Wisconsin. He said, the game changer out of all the events we've had so far is the pavement temps. Every treatment we've used works to a T because our pavement data is so accurate. Multiple city employees that live in neighboring communities have asked how we are so successful while reducing salt use, pavement temps, and suggested application rates. Now, I know the City of Oak Creek has done a really great job at reducing the amount of salt that they use, and Tyler and I are actually going to be on a joint session at the Salt Symposium in August. So he's going to go into more detail about how they've done that and the actual numbers. So I definitely recommend joining that or looking that up if you're able to. And you can go next slide. Okay, so in summary, state of the industry, we all know this, the overuse of road salt is under more scrutiny lately. Public works teams are modernizing their infrastructure to a certain extent. The one thing I do want to touch on here is experience. It is great to have experience. If you have 30 years of experience, it's fantastic. You kind of know your road network in and out, right? But the one thing I will say about the going with your gut decision making is you don't have the justification on your decisions. So if someone comes, we all make mistakes. If there was a bad decision and someone comes back to you, maybe it's in the media, maybe your administration, maybe your residents, with data, you now have justification as to why you made the decision you made. So if you want to skip a few forward, Allison, some of the benefits of the data are targeted treatments, more precise application rates, reduced call-outs, reduce costs and better salt management, and then quality of life and transparency. And ultimately, this visibility just allows you to have more confidence, more trust in your planning ahead of time. And the last thing I'll say too is, if you're just getting into the research phase of this, call your neighbors, see what they're doing, work on it together. Because ultimately, the more people that engage with this network and join this network, the better the forecasts are going to be, and the better the benefits are going to be. And that's it.
Excellent. All right. And I'm back here. I'm going to switch over from the slides to the Zoom YouTube screen. So thank you again. I'm going to be a little distracted here. I'm just going to type into the chat because I don't see any questions yet from our viewers. It'd be great to have some. So I'm going to put my email in. If that's easier, you can email me a quick question, or you can always type those into the chat as well. For Eric and Jason, I'm sure they'd both be up for taking questions, afterwards too. I caught their emails were on the earlier slides. But we'll give people a second just because there's a little bit of a delay between what we're seeing here in our Zoom call and when things are on YouTube. So let me just pull up this. Okay. It's looking good. Great. Yeah, Eric, I know I saw that you and Tyler are co-presenting, so that's really exciting for the SALT Symposium. If anyone hasn't heard of the SALT Symposium before, it used to be an in-person event, but since COVID has been virtual, and it's put on by Bolton and Mank consultants out of Minnesota. At least that's where they're headquartered. I know they kind of work around the country a bit, and probably would like to continue to do more around the country as they've developed a low salt kind of design in terms of thinking about when we're going to build, whether it be the buildings, parking lots, how do we think about winter maintenance from the get-go and not create, nightmares for the people who have to deal with winter maintenance. So kind of forward thinking there. And obviously they've been champions of low salt work for a long time. And yeah, Eric, I know you mentioned Madison, Oak Creek, Jason, I believe, do you know some of the people in Wisconsin that currently use frost systems? I know Walworth County does.
Yeah. Yeah.
Um,
Yeah, we have 2 or 3 counties out there that are using the systems currently and sharing data.
that's great. Yeah, I have heard great things from both users of both of your remote weather stations. I have seen a few people, I don't know if you've heard of this, using game cameras. It's like the cheapest. Obviously, they don't have the pavement temperature data. It's far less than Eric, kind of what you were saying, but
Yeah.
it was St. Louis County in northern Minnesota, and they're the largest county by geographic area in Minnesota. And you got one person trying to make a decision from like a certain part of the county. And it's like, well, we don't know what's going on tens of dozens of miles, to the north of us. And then you add in lake effect there too, as well, or lake enhanced, I guess. But I
Yeah, I'll
don't.
echo something that Eric said earlier, which I appreciated. It's like I think people going out and working with data is, my father's been plowing snow since like 1950, and like back then he wasn't paying attention to anything. It was just go, just get it out of the way. And when I talk to him now and he's like, what are all these points of data that you're worried about? You know what I mean? Like it is kind of foreign, right? And
Mhm.
the machine learning and AI components, for many in this industry are a little bit, I mean, it's nuanced, right? But going out informed is so much better. I mean, even most people don't go out informed. They just go out to do a job and come back, right?
Mhm.
Whether it's a municipality or it's commercial, giving them a little bit of data as they head out, like a start time or what am I turning my salter up to, just giving them that data
Mhm.
could ultimately save, so I'm 100% behind where Eric's coming from too.
Yeah, and I
Yeah.
think an important concept too is being able to understand the data and being able to apply it
Yeah.
appropriately. So
Mhm.
like there are instances, and I know I put a lot in front of people here today, there are instances where you can have data overload. So
Mhm.
making sure you're using that in the correct way is just as important as being able to secure that data.
Yep.
No, definitely. And Jason, I appreciate that you had said, like you give this data to those operators when they go out, right? Because so
Sure.
often it is, like you said, they kind of like, oh, you guys can, lighten up a little bit today. Like, what does that mean,
Yeah. Yeah. Or the
versus,
opposite, what we don't like to hear is just salt
yep,
it away.
just go for
You
it.
know?
Here are the keys, like
Yep.
get the job done. Yeah, but I've seen in the city of Stevens Point, and if you guys haven't yet, like would highly, highly recommend that webinar, our
Mm.
Saltwise Stories City of Stevens Point, because they have road temperature sensors in the cabs of the truck. And then they've got a little cheat sheet. So this gets to Eric, what you just said too, that kind of like application piece, right?
Mhm.
So they're like, okay, we're in this kind of temperature band. Like this is how many pounds per lane mile we want you to be
Right.
putting down, and it's all the salt's pre-wet. So those are pretty low rates.
Mhm.
But they can just kind of look at the temperature data, kind of look at where they need to be. And it's there, like just makes so much sense.
It's great.
Yeah, they've had huge, huge success. So I don't see any questions in the chat. We've got kind of a quiet audience today. So I think I'm going to let you guys off the hook here. But thank you so much for joining us and look forward to, yeah, kind of seeing you, Eric, next week in Grand Rapids and Jason, I guess some of your
Yeah.
team as well.
Yep.
Yeah, and the only other thing that I would say would be if you have more of these kind of stories, it sounds like Cranberry Township or whatever, whoever it might be that have had some real successes, I would love to potentially work with you or maybe be, in touch with them. I think I might reach out to Cranberry Township since I know that I mentioned earlier, there's that group in Pennsylvania that's really trying
Mm.
to move things ahead and they don't really know who the champions are in their state right now.
Cool.
Because we're making just various case studies that kind of show, okay, these were the changes that were made. Maybe it's some new equipment or, policy changes. And this is kind of how our salt use has changed, the dollar savings, et cetera. Because I'm using that for my conversations with legislators, but I think just like everybody in general likes, seeing those stories. So we're just making some real short kind of one-page summaries of some of the successes out there.
Yeah, absolutely. And Cranberry Township will be at Snow, Allison, so I can introduce you.
Okay. Yeah, no, that'd be great. Cool. All right. Well, thanks again. Really appreciate it. And yeah, be well. Safe travels to, sounds like both of you guys are on the road a bit.
Just a little bit.
Nice to meet you guys.
Yeah. All right.
All right,
Bye-bye.
bye, everyone. Thank you.
Yeah, thanks.
Yep.